Okay, hello and welcome back to the OK Sips Lab and Studios. We're doing another little test here. What happens in our panel system, we use our high strength composites and our foam core, but we don't have any studs in there. There's no need to have any studs in there to carry the weight of this wall, so it's not built like a traditional home. This is truly a sit panel. It's a structural insulated panel. Now, a lot of people ask, well, what happens if I want to hang something heavy, such as a cabinet, or if I want to put a rim board around here and put floor joists on? Well, it's very, very simple. Underneath, we pre-make these in our foam cores, is we'll take a piece of this roll form galvanized track, which is, this one happens to be an 18 gauge 3 5/8 track with a 2-inch long leg, and we'll cut in with a router, and we'll go ahead and make a space for that right inside the foam, and then we lay this in underneath the panel before we manufacture the panel, and this piece of steel is all glued to the skin on the outside, and that's our attachment point for heavy items. So we can add this in kitchen areas, an area on the wall where you want to place a television, or any other area where we need to have structural reinforcement. It's very easy ahead of time to take the plans and decide where we'd like to place these, and we can place these tracks. We can also use smaller profiles on this one. We could just put an angle in there, for instance, or we could even use heavier ones if we felt the need to do so. So what we're going to do is, we've got our jack set up over here and our pressure here, and we've got a plunger onto a 2x4, and we glued a 2x4, which is how we install cabinets, and screwed it to the panel with 3 screws to hold it good into the steel. And we're just going to see how much strength our panel has. What we expect is, after we put a certain amount of force, we're probably going to have a little crack right in here where my finger is approximately, I'm guessing, where the foam is going to break. So let's have a look, and we can see our gauge right there plainly. And I'm going to start pumping that up, and we'll go slow to start with, and we'll get it up to about 500. David can tell me when to stop. We can hear some creaking and cracking. I believe that is probably just the 2x4 compressing. That we've got this 2x4 here, and the one right on our plunger is starting to compress a little bit, and I think this is moving up here too. We've got, in order to make our frame nice and strong, we've screwed a double 2x4 to the top of it, and it appears like some of those screws might be starting to pull out, because we're going to put some pretty amazing amount of pressure on here. So we're going to lift it up a little bit more. I can see our test frame is actually moving. We're moving right here. We're pulling those screws out of the test frame. So I think we're going to start over again. We're not making any damage to our panel whatsoever. We're going to cut the film for a minute. We're going to go ahead and take that back down to 0, and I'm going to reinforce the test frame a little bit better. Okay, we're back. Now what we've had to do is reinforce our test frame here. And again, we've got a 2-inch LVL in here, braced down with 45-degree angles. We had 2 screws in here and 1 in the back. We actually put another screw in here, 2 more of them in the back. We reinforced it the same on the other side. Our panels are incredibly strong, that we're taking this entire reinforced jig that we're making and we're moving the jig instead of doing anything to our panel. So that really goes to tell you about the high strength fiberglass skins, because of the high tensile strength of the fiberglass on here. So we're going to go ahead and pump it back up. And the way I believe this jig works is I'm actually getting more than what I'm showing. But just for intents and purposes, we're going to call it 1-to-1. But because of the diameter of our piston, I think we're really getting 1.77 pounds per every one that's showing up over there. So let me know when we get to 500, David. Okay, we're well above 500. I can hear everything creaking and cracking. We've got no damage to the panel at all. Looks like we're completely intact. We're maybe getting a little bit of bowing here. It looks like this is starting to roll over the 2x4 ever so slightly and compress down in here. Like I said, what probably will happen is it's going to go down here and break right there. We'll see if I'm correct. Okay. And tell me when we get to 1,000. Now we're moving. Here we've got a problem. If you want to show this on the camera, I'm actually breaking the 2x4 right here. The 2x4 is splitting all apart, and that's where we're losing our pressure there. We're not having any type of failure on the panel whatsoever. We're actually splitting the 2x4 wide open, and it's split on the back over here too. We can see that. So we'll have to configure this jig a little bit stronger. But we're going to go ahead and just, I don't think we're going to get any kind of failure on our panel, but we're going to see how much pressure we can possibly go up to. I think it's going to tear the 2x4 off now. I've kind of changed my mind about what's going to happen. Okay. And there we can see that with the, it's pretty simple. Just now we've got a little, there, we finally were able to damage our panel. So we pushed this so far by breaking this solid piece of wood right there. We actually managed to delaminate our panel a little bit right there. So that would be a very, very difficult thing to do in real life on a constructed building with a conduit hanging off the wall. So that's all we've got now. We're going to have to make this a little bit stronger so we can get more of a true measurement of what we have there. Thanks for tuning in. Look forward to more videos soon. And here we're going to release it back down, and you can see it all falling right back down.